We're going to go ahead and make a foldable, and we'll make a couple of these when in Algebra 2 Trig. And this is just usually when I do something to help serve as a review guide at the end of a chapter, or in this case, review of a concept from Algebra 1. I like for us to have just a quick and easy reference. So if you can find a colored sheet of paper or a white sheet of paper. If you don't have any white sheet of paper or colored paper, that's fine too. Just grab a blank sheet of line paper. You'll need the front and back of it. And then let's fold the, what we're going to do is fold according to what you see on the screen. Hot dog style, which means either landscape, you're holding the page horizontally, and you're going to fold it not quite in half, but down so that you leave about a ½ inch at the bottom. So I wrote a ½ inch there at the bottom for a title. So that that title should be able to peek through from the top. And then what we'll do is create 3 equal columns. The best way to do that is to fold inwards towards the middle so that the column on the right and the left, they overlap each other. And again, you're trying to create not 4 columns, but 3 columns. So we don't want to fold it in half and then half again. So the 3 columns are going to be titled slope-intercept form at the bottom, point slope. So we're going to write that on the ½ inch. So slope-intercept, point slope, standard. And then the title of this graphic organizer is going to be called linear equations. The blue dotted lines that you see that I'm drawing arrows towards are just fold lines. So that fold line should correspond to these fold lines at the bottom. And once you have that complete, go ahead and open up your graphic organizer. And those fold lines are going to be what you see here. And at the bottom, you should see the title slope-intercept form, point slope form, and standard form. And then within each one of those 6 boxes, we'll fill it out with equations to know and examples. So at the very top, the equation that we associate with slope-intercept form should be y equals mx plus b. We'll go ahead and put a box around that, and we'll discuss what to do when we are given, let's say you're asked to write an equation of a line with slope of 1/2 and y-intercept of 3. So we simply identify that m is 1/2 and that b is 3, and we plug everything in. So every equation that we write, we should have an x in it and a y, x being your independent variable and b being your y being your dependent variable, so that is the answer to an example where they provide you the slope and the y-intercepts. Below in the second row, we're going to graph something that's in slope-intercept form. So graph y equals, let's do a negative slope, -1/2 x minus 2. So we start always with the y-intercept. So the y-intercept in this case is the -2. And that's kind of, so I'll put a little 1 here, as in we start with graphing that. The y-intercept is where you live on the y-axis. So we're going to identify where -2 is. It's down on the bottom right there, -2. And then the -1/2 is your slope, or it tells us directions. So this is what we would do next. Directions, how to get from the point that you're at, the y-intercept, to the next point, and then from that point on to the point after that. So it's a pattern in which you get from one point to the next. So sometimes I'll say it's a map to get from one point to the next. So according to this map, when we see -1/2, that tells me that I can think of this as either -1/2 or 1 over negative 2 and not negative 1 over negative 2, which then would be positive. So if I were to, let's say, take the interpretation of negative 1 over 2, that would mean rise over run, that I would go down 1 and then right 2. So down 1, right 2, and that's that point here. The other interpretation is a positive one would be that you go up 1 and instead of going right 2, we go left 2. And we still fall along the same pathway. So the line would pass through those 3 points, and we would say that would be our equation of our line. And then in our point slope column, we're going to write out a few equations here. Point slope form, I'm going to write a little bit smaller here, is y minus y1. And actually, you know, the y1 I'm going to write in a different color. The y1 and let's keep y minus y1 equals m times x minus x1. And I'm writing the m and the y1 and the x1 in a different color because these are the values, these are numeric values that you're eventually going to substitute in. M is still slope. X1 and Y1 is any point on the coordinate, on the line that we're trying to find the equation of, or that we're given to plot and then to graph the line. So in this next part, I'm going to give you guys an example, and the top part will be write the equation of a line. The bottom part will be graph if you're given the equation written in point slope form. How do you graph from point slope form? So we'll begin with the equation. Let's say find the equation of line. And it's going to say in slope-intercept form, and I want to make mention of this. I left it in point slope form column, but this is, in many examples, will say write it in write something that we begin in point slope form into slope-intercept form, but it doesn't tell you that you have to start with point slope form. So that passes through 5, 1 with slope of 1/5. So we would take the coordinate points that we have, 5, 1, and the slope that we have 1/5, and plug it into the equation. So y minus the y coordinate, which is 1, plug in the slope, m, is 1/5 given to us, and then the x coordinate is x1, so x minus 5. And you'll notice that we end up with a y in our solution and an x, which is what we want. Not an x1 and not a y1. And then because it asks us to write it in slope-intercept form, you'll remember that that would involve us distributing the 1/5. So y minus 1 equals 1/5 x minus 1. And then finally solve the rest of the way, and we get y equals 1/5 x. Add the 1 to the other side. -1 plus 1 is just 0. And then another formula I'm going to add to this section, hopefully you have a little bit more room than I do here, is the formula for slope. So I am just actually going to write it over there, and I know you guys have more room because on my own graphic organizer I do. So anywhere below that in that same box, I'm going to write how do you find slope if you're given 2 coordinate points. And so most of us associate slope with rise over run. Rise rhymes with y's, and it's the y's that are on top, so it's also called change of y over change of x. Change of y as in the difference between the y coordinates, so y2 minus y1 over x2 minus x1. And this would be used in conjunction with the point slope form if we were given 2 coordinate points and not provided the slope to begin with. So in some cases, we would have to find the slope first. And lastly, in the bottom, we're going to graph something that is already in y-intercept form. So let's say y minus 2 equals 1/2 x minus 3. And I just gave you a different equation here. So let's say so the options are I can distribute, get y by itself, and then graph it in slope-intercept form. Or I can just take the information from the point-slope form and then graph from there. So if I look, I know that the slope is 1/2 for sure. The coordinate point, so the point that it passes through is the opposite of -3 is +3 because it's x minus x1. So I just want x1. So x1 is +3. If we apply the same logic to y minus y1, where this part right here is minus y1, then I know that y1 is just +2, the opposite in sign of that. So that means that this line must pass through 3, 2. So let's plot 3, 2, 1, 2, 3, up 2. Must pass through 3, 2. And then from there, from that point, we use slope to get to the next point. So up 1, right 2. Or down 1, left 2. And we get a line that passes through that point with that particular slope. Our last column is on standard form. And standard form, I didn't box slope-intercept form, so I'll do that for you here. Standard form is ax plus by equals c. And a few things to note about a, b, and c. What are a, b, and c? So we know that our equations of lines should have x in it and y in it, and everything else is numbers. So a, b, and c are what we call real numbers. Okay, a few things can't happen. What can't happen is that a and b cannot be equal to 0, because if they were, they would no longer be a linear equation. Also, a, b, and c must be integer coefficients, meaning that we can't have it be fractions. And then certain textbooks will say that a must be positive in order for it to be standard form. And with that, it depends on the textbook. We'll say for this course that it's fine that a is positive or negative. It's any integer coefficient. It just can't be a fraction. So say you were given something in standard form and they want you to write it in slope-intercept form. So write in slope-intercept form. So one thing to note is that if you're asked to write the equation of a line, you're never going to be asked to start with standard form. Standard form is always something that you end in. So for this one, we'll say that we'll change this. I have the example written a certain way, but you know what? I think I want to make it so that I write in standard form instead. So this is where I think students kind of have a hard time picturing. So the equation begins in, let's say, y equals 2/5 x minus 2. So it's actually begins in slope-intercept form, and they want you to write it in standard form. So standard form would mean I need x's and y's on one side. So I'm going to go ahead and subtract 2/5 x to the other side. When I do that, I get -2/5 x, and I'm trying to squeeze it in this box. So forgive me because I'm not writing it right below that. So I subtracted 2/5 x to the other side plus y equals -2. Now the next thing is that it looks like it's close to being in standard form, but the problem is that we have a fraction here, and we can't have fractions. We need integer coefficients. So that means I need to multiply everything through by 5 to get rid of the fraction. And that includes the y and it includes the -2. So when I do that, I am going to multiply everything through here by 5. And distribute the 5, I end up with -2x plus 5y equals -10. And that's in standard form. Now, how do I graph in standard form? let's say we were to graph that equation, negative 2x plus 5y equals negative 10. We would use something called X-Intercepts and Y-Intercepts. So in order to find the X-intercept, you would set your y to 0. An X-intercept is any point on the line that falls on the x-axis. So any point that falls on the x-axis has a y-coordinate of 0. So to find our x-intercept, we set y to 0, and we end up with negative 2x equals negative 10, or x equals 5. Well, let me fix that. I started to write it as a coordinate point. So we would write our coordinate point as 5, 0. To find our y-intercept, we would set our opposite variable, x, to 0. And same reasoning logic, the y-intercept is a point that falls on the y-axis, so therefore the x coordinates are 0 there. If you plug in 0 for x, you're left with just 5y equals negative 10, so y equals negative 2, or 0, negative 2. Please write all your x-intercepts and y-intercepts properly as coordinate points in this class. So you're not going to write x equals 5 is the x-intercept, because that x equals 5 is actually a vertical line. And same is true for the y equals negative 2. It's a horizontal line, so we want to make sure that we write it as coordinate points. And then from there, let's plot 5, 0 and 0, negative 2. So 0, negative 2 is down here. 5, 0 is over right 5, 0. We need at least 2 points to make a line. So